Hello, welcome back to the LOOC. In this segment, we are going to learn about classes, objects, and methods. This is a first introduction. We'll learn more details in later segments. In this segment, we'll learn how to declare a class and use it to create an object, how to implement a class's behaviors as methods, how to implement a class's attributes as instance variables and properties, how to call an object's methods to make them perform their tasks, what instance variables of a class and local variables of method are, and how to use a constructor to initialize an object's data. So starting on, classes are like blueprints, such as an engineering drawing of a car, and parts of an engineering drawing hide detailed mechanisms and just indicate the role of certain components like an accelerator pedal. And before we can drive a car, it must be built based on the engineering drawing or blueprint. In computer science, in case of classes, a method describes various mechanisms by which we perform a task, and a class is used to house a method or multiple methods, just as a car engineering drawings. In essence, a class is a blueprint of similar objects, similar programming constructs, provide a general blueprints for many of them, and as such it performs a generalization or an abstraction of the commonality among these objects. And another example could be a class represents a bank account, and it can contain a method to deposit money in an account, another to withdraw money from an account, and a third to inquire to find out what the current balance is. Obviously, we cannot drive a blueprint, so we have to create an actual car from a blueprint. Similarly, we have to build an object. An object is an instance of a class, and we can instantiate a class many times and have many objects. And once we have the object, you can send messages to them by making calls to the methods that they have, and this mechanism makes them useful. In addition to methods, in other words, tasks that a car can perform, it also has attributes like color or number of doors, or the amount of gas in it. And these attributes are represented in the blueprint, and therefore they are represented in classes. And these attributes we also call instance variables. It's mentioned here that an instance variable really means attributes that of which every instance has its own copy. Later we learn about static variables that are shared within a class, but at this point we are talking only about instance variables. Attributes are there, but they are not necessarily available and accessible directly. So for example, customers are not expected to walk in a bank vault to count their money. Instead, they ask a bank teller or an ATM or an online account to find out what their balance is. Or drivers are not supposed to disassemble the car and look into the engine to find out how much gas they have. Instead, there is on the instrument panel there is a gauge that shows how much gas is in the tank. So as a result, we need get accessors and set accessors. Sometimes get accessors called just accessors, and set accessors are mutators to manipulate the attributes. As a first example, we are going to create a gradebook console application that will contain a gradebook class declaration. It will look like that. So in code, after the using system directive, we have the definition of a class, public class gradebook, and it contains one method at first, only one display message, which is just a message displayed to the user, welcome to the gradebook. So let's open up Visual C# and let's create a new project called gradebook. Takes a little bit on my computer, unfortunately. Not the fastest thing in the world. Like, really not the fastest thing in the world. Okay, so we want Visual C# and we want a console application, and it will be called gradebook, and I want to create it in a different location than the default in my case. So for example, I can go on my computer, I can go to the C drive and navigate to the location where all the LOOC related content is. So let's see here, game and LOOC and LOOC projects. So that will be the folder, and we are going to create the gradebook application as well as the gradebook class within it. It takes a little while to come up. I hope yours is faster than mine. So while it's coming up, looking at the code again, it will have a file called gradebook.cs, and within it will have a gradebook class. That's our purpose. Let me see if it's ready yet. So here it is. Now it has a program.cs. That's not the file we want. Eventually we are going to use that file as a test a program file, but at this point we want to add a new file that contains our gradebook, and unfortunately it's still not behaving very well and not very fast. So what we want to do is add a new item, and the new item that we are going to do will be a class file. Instead of class.css, it will be called gradebook.cs, not CSS, sorry, CS, like that. So there is our gradebook class. Actually we don't need all those directives, only a few, actually only one, the first one, systems. I'm removing the redundant ones, and there is our class gradebook. We don't necessarily have to include it in the simplest case as a separate namespace. So this is just the outline of it, and we will also declare it as a public class, and that will indicate that it will be available to code throughout our application. So what do we put in there? The first thing we put in there, and I have to set my editors differently than it is currently. So under options, in text editor, for all languages, I want to set the tabs to 2. We did that before. Insert spaces like that. And so we are going to display, that's just a comment, a welcome message to the gradebook user. So the method will be public void display message, like that, and it starts and ends. So end method display message. I also misspelled the word public. And so that's our method, and maybe we can comment that this is end of the class gradebook. So we are all set, and in the display message method there is only one thing to do. Console dot write line that we already know, and a string in there. Welcome to the grade book, semicolon to close it, and that's our gradebook class. We can save this. So in gradebook.cs is a single method in there. Now in our other CS file, which contains our main program, we are going to create a test to test it out, and in particular we are going to change some of the properties of this file, such as its name. Make it gradebook test, and all references to it will be modified. And since we didn't use the namespace gradebook anyway, we don't really need it here, and we are just going to use a public class again, gradebook test, and rearrange the indentation a little bit here, and that's my main static main method. And as typical, in case of classes, we start with a comment. Main method begins program execution, and within it we are going to make a call in which we create an object, and then we are going to use its display message. So the first thing to do is create a grade book object and assign it to variable, say, let's call it my gradebook. And the second thing we are going to do is we are going to call my gradebook display message method. So that will come here. So let's look at how to call a constructor to create an object. Well, we have to declare the variable of the type gradebook, which is available because we included it in the project. The name of the variable is my gradebook equals, and the keyword new, and then the gradebook constructor, the default constructor, is already available by virtue of having a class. And then we are ready to use that variable and call its display message method, which takes no argument, and therefore our program is completed. So the important thing to remember about the first line, that what we are calling here is a method called gradebook, which is the same as the name of the class, followed by round parentheses, indicating that actually is a method call or a function call called a constructor. Every class has one, even when we didn't write one yet, but it's automatically inserted as a so-called default constructor, and that has to be called using the new keyword to create a new object, and the new object is stored in the variable my gradebook, and it's of type gradebook. So in a sense, defining a class created in effect created a new type of data, a gradebook type of data, which is somewhat similar to like integer or float or decimal and other native or primitive data types available, but this is actually a user-defined data type. So that completes our first program. We can save it all, and we can build it. I recommend rebuild for building purposes. And let's see the output. If we don't get any error message, then we didn't make any mistakes, so all succeeded. So that's good. And then with Control F5 we can run it. It shows up in the console window, and it actually indicates that it did what we wanted it to do. So side by side the code and the output. So we created a my gradebook a variable which is of type gradebook, and it actually, its value is a gradebook object, and then we use this gradebook object referenced by the variable my gradebook, and we use the dot notation to invoke one of its methods. Actually there's only one, display message, and that's the one we are invoking. So if we look back to the gradebook class, we see the message, display message, as being there. So that's why we see the output what we are seeing. So that's how we create and use a class and complete the program. So that's our first version. as seen here. So going on to the details, the keyword public is an access modifier. They determine accessibility of methods, objects, classes, and so on. So both the class and its method is public, meaning it's available basically to any code segment within the application. Generally, access modifiers determine the accessibility of properties and methods. Public indicates accessibility all across our program, and will encounter other modifiers such as private, protected, and so on. The class's body is enclosed a pair of left and right braces, like there, the ones up and down, and methods declaration also begin with a access modifier, public in this case, to indicate the method can be called from outside the class itself. The keyword void, known as the method's return type, indicates that this will not return any information to the calling method. So that's why our display message is void. If it returns some value, integer, float, decimal, string, and so on, then that would be its return type. And if it's not void, then it returns some value. An example being there is int result equals square 2. So we can think of square as a method that returns the square of a number. In this case, the square of 2 being 4. And in this case, the square method would have had a return type int. And that's what we are indicating that we are expecting there. And the body of the method contains the statements that perform the tasks. In our case, there was one, the display message. So we added a new item, gradebook-test.cs. Actually, we modified one that was already part of the program, renamed it, and placed in the code to instantiate the class, create a new instance, a new object out of it using the new keyword and calling its constructor, default constructor, and then send a message to it, the object, by calling one of its messages. In fact, there is only one message. Any class that contains a main method can be used to execute an application. Typically, there is only one per application. And a static method is one that can be called without creating an object of the class in which the method is declared. So gradebook test in this case has a main method, and therefore it can be used to run the main method, and we don't need to create an instance of the class gradebook test. We can look at the UML class diagram for our class. UML stands for Unified Modeling Language, and it's a diagramming tool that is used to create designs in a visual form or a diagrammatic form. And classes that are modeled with the rectangles that have 3 compartments. The top one contains the name of the class, the middle compartment contains the class's attributes, and the bottom compartment contains the class's operations or methods. And a plus sign is used to indicate that the access modifier of the class is public. So this is what it would look, the 3 compartments in UML notation. Gradebook is the name of the class. We haven't added any attributes at this point. and added one public method display message. If it was something else like private, it would have a minus sign and so on. The plus sign indicates it's a public method. In our case, display message had no parameters as indicated by the two round parentheses that show that no parameter was necessary to be passed in to this method. However, we can write better methods if we pass parameters to them. So a method can specify parameters that add additional information that might be necessary to perform a task, and this supplies values or argument. A method call supplies values, arguments for the method's parameters. So we've seen examples of this. Console.writeLine takes an argument, namely a string, that we want to display. So we are going to improve gradebook such that its display message method displays the course name as part of the welcome message. And so in our case, the gradebook class will still have the display message method, but it will have a parameter passed in of type string, and it's the course name. It will contain the name of the course, and when the display message is executed, in addition to welcome to the gradebook, it will say welcome to the gradebook 4, a new line, and then this is a format string, so contains a parameter for the first content string course name. So it will be substituted in place of where the 0 sits. And our gradebook test class, which contains the main method, so it will do the running of the program, will now still create a gradebook object. However, in the program we will ask the user to enter a course name. We are going to read it in as name of course, and then output a blank line, and then we are going to call the display message with that name of course, the variable name that contains the string that is the name of the course of the class, to run, to pass to the display message and run the method, and the output will be that. So for example, enter the course name CS 101 Introduction to C# Programming, and that's what we are going to get back. So let's try that. So we are going to modify our display message method in our class, and we are going to add the string course name argument, and when we are displaying welcome to the gradebook, which I misspelled here on top of it, welcome to the gradebook, we are going to welcome the user to the gradebook for a particular class, gradebook, for, and \n for a new line, and then a format parameter, followed by course name, which is our one and only argument, our content argument, which is the same as the course name passed in to the method. Control S to save it, and we can go back to the gradebook test and modify that appropriately. It's already underlined because we changed the signature of the method display message, and it requires now parameters. So we still can create the variable as before, no change there. However, this time we have to prompt the user for a course name. So prompt for and input course name, and the way we are going to use it is use the console object write line method, and prompting the user please enter the course name and semicolon. We have to read it in, so we are creating a string variable called name of course, lower camel case, equals, and then this is a read line, in particular a whole line. That's to read a line of text, and we are going to drop a new line, so just a blank line. So write line with no arguments, that just writes output a blank line. Having done that, now we are ready to actually call the method, and in this case, as further explanation, we call myGradebooksDisplaysMessage method, and we also pass the name of course as an argument. So the modification we really need to do is that within the parentheses I have to pass in the name of course argument. That will be the forgot to comment end of main, and that will be the end of class gradebook test. Control S to save it. So we modified our class as planned. So now there is an argument for the method, and we use that by inputting it from the user. So if we build it, I recommend it often useful to clean a solution, remove old code and compiled components that came from old code, and rebuild it instead of just build, because it forces the rebuilding of all files, not only those that changed, because sometimes if we build only those that changed since the last compilation can lead to errors. So Control F5 to run the program, and it asks for the course name, so CS101 Introduction to C# Programming. I think that was our name, and the program responds by displaying Welcome to the Gradebook 4 CS101 Introduction to C# Programming. So again, putting the code and the output side by side, let's go back first to the modified class code. So our class gradebook has a method display message, but it not takes a parameter, and we use that to display the name of the class in our welcome message. So it now sounds welcome to the gradebook 4, and in a new line CS101 whatever we typed in for the name of the course, and the class with the main method that runs our application now is calls for an input from the user first, the name of the class, and then we use that input after a new line a blank line that we dropped on the console screen, the display message with the name of the class passed in, and therefore we get the right output. So that's our modified program. A method can have more than one parameter, so it's a parameter list. It's comma separated and it's within round parentheses following the method's name. Empty parentheses indicate no parameters, and the calling method will pass in arguments, and those values will be assigned to the parameters. And objects are created with new, as we saw it with our gradebook object. One exception is string, when we can just type a literal as hello, and they are implicitly created by C#. Although we can use the new keyword to create strings as well, but it's not necessary. It's one of the native classes types that are implicitly created. We have to match the number of arguments. We saw the underline when we provided one argument for the display message method, and our old code still didn't have one. We got a compilation error, and not only the number but the types have to match. So if we expected a string type argument as per our code, we had to pass in a string. We cannot pass in an integer instead of a string, because there would be a problem. And accordingly, our UML diagram for the class is modified as well. Still 3 compartments. The top one is the name of the class. The middle compartment is where the attributes would go. None so far. And the third compartment where the methods are listed. One display message, but this time in UML we indicate that the message has one argument, and the syntax is somewhat different than in programming. So name followed by colon followed by the type of it being string. And in the same project, classes are in the same namespace. By default, the namespace is inserted by C++, although we removed it in this particular case. And we can use the using directive, as we've seen, to indicate that we use classes from another namespace. Without using, we have to type a so-called fully qualified class name. So if we didn't have using system, we would have been forced to write system.console.writeLine, and by saying using system, we save us the trouble of having to write system dot in front of every console in the program. Next, we need to talk about instance variables and properties. So this is the time when we are going to add attributes or instance variables as well as properties to classes. Variables declared in the body of a method are local variables. It means that their scope, their so-called scope, is local, limited to that one method, and they are surrounded by the curly braces that constitute or surround the body of the method. When a method terminates, the value of the local variables is lost. It's erased from memory, released from memory, and as a result, we cannot use the information that was in them once the method is over. The related concept in case of classes is the attributes, which are variables but not of a method, but they are variables declared in a class declaration, and they constitute the attributes of the class, which will be the attributes of objects such as color or number of cylinders in case of a car, or balance in case of an account, a checking account class, and so on, or name of a course in a course class or gradebook class. And if each object, that is each instance of the class, has its own copy of an attribute that is known as an instant variable. We'll later talk about static variables, which will be different, but color of a car is can be very different for different cars, so it's an instance variable that each car instance has its own color. In our case, gradebook will now have an instance variable and can be used as it is or modified. So here will be our modified class, gradebook. It has an instance variable which is a private and its type string. It has an access modifier private as opposed to public. Course name is the name of it and string is the type of it. As well as we associate a property to get and set the course name. The property is public string course name. Note how the spelling of the attribute is lower camel case, so it starts with a lowercase c. The name of the corresponding attribute that does the getting and setting of the instance variable is course name but upper camel case, so starts with a capital C. And the property has a get and a set method, one which returns the course name and one which sets it to a particular value that's provided to the set method. So there is a private instance variable course name and a public property that does the get and set of its value. So this will be our modified program, and our method, however, the display message will work without having to rely on a passed-in argument. So it will still display the course name, welcome to the gradebook 4, and comes the course name, but this is no longer an argument for the method itself. Rather, it's an instance variable that is carried in the class itself. Its name is course name in lowercase, and an attribute with the upper C course name provides the get and set methods for it. So it's going to work similarly as before, however, without having to restore or having to resort to a variable passed in for the method. So let's go back to our program. The gradebook class will be modified. So display message will not have any arguments this time around. So it will be there without having to do anything. And as a result, we have to do something with this variable. However, the class itself now will have an attribute, private string and course name. And just to indicate its use, course name instance variable for this gradebook. It's private, so it's not accessible outside of the class, and to be able to use it, we create a property to get and set the course name, and the property will be public on the other hand. So while the instance variable is private because we don't want to allow access to it, just like we don't want customers to walk in the bank vault or drivers, open up the engine to check how much gas is left in the tank. So we make it private. On the other hand, we provide access to it, similar to a gauge in the dashboard or an ATM machine or a bank teller in a bank, via a property. So string course name, same type as the instance variable, but public, and property course name, and within it we create a get method. It's not quite and get, and within it the method will return, we use the return keyword, course name, the value of the course name, and likewise we are going to write a set method as well, and set, and this will set course name to value, where value is a keyword that says that the argument of the set method is to be used, so that we don't have to write it ourselves. So that will be the modification of our class, and as a result, there's one more thing we have to do though, that we are not displaying course name itself, the instance variable, directly, but the course name property, and that implicitly calls the get method on it. Control S to save these changes, and we don't really have to change anything in the test except for one thing, that we don't really need, of course, the display message anymore. On the other hand, we need to in the public, in the test method, we have to enter read in the course name, and originally we are not going to use the attribute to be positive. So a little bit we have to change. We create a gradebook object, and then we say display the initial value for it. So before we even give one, there is an initial value, display initial value of course name. So we can say console write line and initial course name is, and the space course name is colon space, or course name is colon space, and then our parameter and \n and comma the object myGradebook.courseName which is available, which is equivalent to calling the get method on it. So what we are displaying here is that the initial course name is, and in single quotes, the name of the course, to indicate that what it is, when we didn't set it to anything yet, haven't set it to anything yet. Then we prompt for the real course name to be added, and we are going to set it so the console.readline actually will set it. So we are going to say my gradebook dot, and there it is, course name. So let me go back here. I was just making room for a second. Dot course name, and this implicitly calls the set method. Setting is a parameter to be the same, under the name value as the get method would use, which is now the right hand side of the assignment. So the left hand side indicates that we are calling the get method as if setting a public instance variable, but in reality it covers up a private one. It provides a method, and the right hand side of the equations or the assignment equals sign of the assignment is the read line, which actually this is a little bit inconsistent here. So we still want this new line to be there in the next line, but what we really want on the right hand side is the read line here of the assignment, like that. We don't need the name of course variable anymore, and this would be a console. This would be just a console write line to drop an empty line. So let me restore that. So that was just I'll put a blank line. So that's what we want to do. We prompt the user for a course name, and then we read a line and we set the migrate.boot course name to that, and the right hand side is the value that the get method uses, and then we just drop a blank line. Let me also set the line numbers. So Ctrl S to save, and set line numbering, turn line numbering on here. So line number as we did it before, so that I have my numbers my line numbers displayed. So on line 21, on 20 we are prompting the user to enter a course name. On line 21 we read it and assign it to the course name attribute, which is public, but in reality it will set the private lower camel case course name, and then we output a blank line, and following that we call the method, but this time we are not passing course name as an argument. So that was in the previous version. In this version we just display the message, and it doesn't take any argument because course name already took care of it. So let's compare one more time the gradebook class. There is a private instance variable course name, lower camel case, so starts with lowercase c and it's private, and the public property upper camel case course name public string has a get and the set method. The get method just returns the public, it returns the private course name, and the set method sets it, and the value is a keyword that indicates the right hand side of an assignment statement, and then the display message now doesn't need any parameter, which is display the course name property. And in our test program, in the main method, we create the object, print out the initial course name, then we actually ask the user for a real course name, read it in, set to course name, and display the message. I wonder if you can think about what you expect the initial course name would be, given that we haven't set it at this point at all. So let's try if we made any mistakes. So I'm cleaning the solution just to be safe, and rebuilding it. And if I get no error messages, then we didn't make any mistake. And then we are ready to run it with Control F5. And here is the output. Initial course name is, and then please enter a course name. So let's say CS 101 Introduction to C# Programming. And then the program responds back, welcome to the gradebook for CS 101 Introduction to C# Programming. Well, actually I shouldn't have typed in an exclamation point as the name of the course. So let me run it again. Initial course name, notice it's just an empty string, and CS 101 Introduction to C# Programming is the name of the course, and that's the welcome message. So if at this point I put the output and the program side by side, first let's look at the class definition. So here it is. The course has a course name instance variable which originally set to nothing, so it comes back as input as an empty string as a result, and it only gets set after we specify something for the course name property, like this string CS 101 Introduction to C# Programming, and then it responds back using that value. And here is the test program. Again, the initial course name comes back as a blank, as an empty string, and that's why we put the single quotes in there so that we see that what exactly it is. It's an empty string because we haven't set it yet, and string is an example. In general, everything that's created other than a native type is initialized to null or empty string, and in case of string to an empty string. So that's the value we are going to get out of the program initially. So the access modifier private is used for instance variables, among others, but properties and methods could be private too. They are accessible only within the class in which they are declared, and using the private access modifier is known as information hiding. We kind of deny access to them, to code other than the class's own code. Generally, we have to provide one. Instance variables should be private, methods and properties should be public, and if we don't put it, it will be declared private by default. There will be some methods that will be private, but as a general rule, instance variables constitute internal implementation detail, and as such should be hidden, and therefore used with a private access modifier. Meanwhile, methods generally should be public because they are there to be used by our program code. And following this convention helps with debugging because it helps localizing problems. So looking at instance variables and properties, get, retrieve, set, modify, accessors and mutators are the controlled way we provide to manipulate the values of instance variables. And once we define a property for an instance variable, we get a pair of accessors and mutators that handle the details, and we can use it just like if it was a publicly available instance variable. In case of get, it uses a value, and the right hand side, like I mentioned, like gradebook.course name is of an assignment, is used as the value. It implicitly executes the get accessor or modifier, which returns its value. The set is defined by the keyword set, and it's also in brackets, and when they do the set, the right hand side is used as value. So in this case, that text, and does not return any data, and here is again the program that we wrote that shows the use of the course name property to create and manipulate a gradebook object. Also, that local variables, that unlike local variables, instance variables have a default initial value. In case of strings, it's null. That's why we see the empty string. When we display a string variable that is null, we see no text. We see an empty string, and that's what we tested in our code when we said the initial value, and that was none, and therefore it appeared as an empty string, as no value, because strings as instance variables are defaulted to null. In case of UML class diagrams, we now have a property, and they would come into the middle part of the UML diagram, the middle compartment, and attributes in UML are indicated by the word property in so-called guillemets, that kind of angled quotes, and instead of the words public, private, and so on, we have a visibility symbol, plus sign for public, minus sign for private. So in our case, the UML diagram, class diagram for the gradebook class will look now like this. The first compartment is the class name. The second compartment now has a property, course name, uppercase. It's public. The plus sign indicates that it's public. The guillemets indicate that it's a property. And then colon string specify that its type is string, and it has a public method display message. So software engineering practice is that we use properties with set and get, which are public, to handle private instance variables, and they can even be auto-implemented. So if the two accessors, or the set accessor and the get mutator, do nothing else than return a value and assign a value, there is an auto-implemented or automatically implemented properties that look like as indicated here: public string course name get, set. So it's kind of a shortcut to indicate that it is a property. Implicitly behind it, we can think of it that there is an implicitly created lower camel case, so lower course name private course name instance variable, but we don't have to explicitly include one, because that's what it's auto-implemented, so that we don't have to implement it. And we can modify the logic of the get and set if we want. One more thing we have to look at is the difference between value types and reference types. Value types simply contain a value, like here, like an integer variable called count equals 7, then it simply has a value of 7. A reference type contains not the actual value, but a memory address, the location where the value is stored, like here. And reference type instance variables are always initialized by default to null. And client code must invoke a method to refers to a reference type. So in this case, for example, within the gradebook object, there's a gradebook object which is a course name within it. In this case, my gradebook, which is a variable name, doesn't really contain the actual value, because the value itself is an object, so it's a kind of a composite data structure. It cannot be just stored directly in a variable. Instead, the variable's real value is the memory address where that complex data structure making up a gradebook object is located in the memory. In particular, it points to the first memory location, because an object generally takes up many memory locations, not just one. So the basic difference is that in case of a value type variable like count, here integer, the value of the actual variable is 7, that is on the right hand side, and the identifier refers to that value directly. In case of a reference type, such as when we are dealing with an object, a composite type, the variable that refers to it, my gradebook, is not storing the actual value, because it's not a simple value. It's a composite, and therefore instead of storing the value, it stores the memory location where the storage of that object starts. And generally, a lowercase named variable name int double, float, decimal, and so on, native types are typically value types. Meanwhile, capital started upper camel case like gradebook indicate a reference type. Other than simple type or enum struct, which are value type, everything else is a reference type. So an account type variable account1 indicates that account is a variable that references to an account object, so account1 will carry a memory address in it. The next thing we have to take a look at is how we create objects or how we initialize objects using constructors. So there is a special type of method, a constructor, that is used to initialize an object of a class to create an instance. The new operator, new is a keyword, as we've seen it, calls the class's constructor or one of the class's constructors, because there can be multiple of them. And even when we don't write one explicitly, the compiler always inserts a public default constructors with no parameters. So every class is a constructor, even when the programmer doesn't write one. So there is implicitly one defaulted or inserted, the so-called default constructor, and what we need to know about it, that it kind of initializes everything to null or leaves uninitialized. So it may not be what we want, but it's kind of creates kind of a blank object. We can think of it that way. And then it's not appropriate for us, then of course we have to use a different kind of constructor. So here is an example. If we want to go beyond default constructors that kind of create blank objects, the kind that we saw when we first used the gradebook class and the initial class name was a null, we can provide our own constructor so that some kind of custom initialization can take place, like in this example, when we want to pass into a constructor the name of the class to begin with. So we don't start with a blank object with a class name or course name being null. Instead, we want to create right away with a course name properly set. So a constructor as a method can also receive an argument or a parameter, and it's basically a method like any other, with the difference that its name has to be the same as the class name. So if we want to write a custom constructor for our gradebook class, then we do it as shown here. So the public class gradebook first of all has an auto-implemented property course name. So note that there is no need for now to separately declare the private lowercase course name instance variable. That's implicitly done. So simply writing the single line public string course name get semicolon set semicolon in braces takes care of the whole business. This shortcut basically sets in motion the whole auto implementation mechanism that implicitly creates a private instance variable and provides a public property with the get and set accessors, or the get is an accessor and set is a mutator, kind of auto-magically without we having to write a code for it. And then in the highlighted area is the constructor. Initializes the auto-implemented property course name with string supplied as an argument. So public gradebook. Note that there is no return type because it's a constructor. So constructors are special in two ways as methods. They don't have a return type, not even void. And secondly, their name is the exact same as the class, so gradebook. And then they can take an argument, in this case string name, and the course name property is set to the name. Note that this kind of assignment, when it's a property is involved, it implicitly indicates that the set method was called. And then the display message hasn't changed at all. So so a few things we have to know about constructors. It must have the same name as the class, can have a parameter list, and has no return type, not even void. And then when we want to use it in a test program, then we can actually create two different objects, gradebook1 and gradebook2. Both are call the constructor with two different course names. One is CS101, Introduction to C# Programming. The other is CS102, Data Structures in C#. And then we display them. So display initial value of course name for each gradebook, and this is the exact same write line as we've seen before, but we got kind of an empty string because null earlier. Here we are going to get the proper names back, because when we constructed this object, right into the constructor we passed in the appropriate string. So we are going to see that output. So let's write these programs. So we modify gradebook.cs again. So there is no need in this version for the private string course name, the instance variable. Okay, some difficulty deleting it. We have a property, but it will be auto implemented, so we can put it in the command then. Auto implemented property course name. Try to delete this. Course name implicitly creates an instance variable for this gradebook course name. That's why we could delete it, and then the code is much shorter than what we had there, because in reality it's simply being auto implemented. All we need to say is course name and then get semicolon set semicolon. We don't need a semicolon at the end of it, so that takes care of the property just like that, because it's auto implemented. And then however, as a new component here we are writing a constructor. So constructor initializes auto implemented property course name with string supplied as argument. So it's public, because it's a constructor, gradebook. It has no return value, and its name is the exact same as the class, and it has one argument name, and when we create it, this will be the end constructor. Then all we do is use our auto-implemented property course name and set it to name, the string, and that takes care of it. So note how short this code is because of the auto-implemented use of the auto-implemented property. And the display message remains the same, no need to change that at all. So Control S to save this. So again, here we used an auto-implemented property, so we didn't have to write any code at all. It's kind of auto-magically done. And then a constructor that takes one parameter and sets the property to that. Display message, no change. If we go to our gradebook test, then there will be changes here, because first of all we create two gradebooks, like gradebook 1 and gradebook 2. Being variables, they are lower camel case, so gradebook 1. But the constructor now requires a parameter, so the first course will be called, say, CS 101 Introduction to C# Programming. That might be the name of the first one. And we have to remember here that this is a constructor invocation, and the same thing happens on the next line, where we create a second gradebook object like that. So this is gradebook 2. But the name of the course is different, namely it is let's say CS 102 CS 102, and that class name is data structures in C#, which is an interesting topic, probably nice course too. So that's another constructor invocation. And then display initial value of course name for each gradebook. So this will be 2 lines, so instead, gradebook 1 course name is, and gradebook 1 course name, and the same for gradebook 2. So I'm copying this line to save typing like that. So gradebook 2 course name is gradebook 2 course name, and that's all we do. And in this case we are not going to call the display message, actually just writing out the names of the gradebooks, and we also don't have to prompt the user to enter them, because we right away entered them in the constructor. So let's Control S to save this. Let's test. So let me clean the solution just to be sure that there is no remnant of old code or old files left. Especially for complex projects, it's useful. And let's rebuild. See if I mistyped anything or made an error, but no. And then with Control F5 we can run the program. And here it comes. So gradebook 1 course name is, that's the introduction to C# programming, and gradebook 2 course name is data structures in C#. So let me put together next to each other the output and the program. So we are displaying the course names, new line after each. Introduction to C# programming, data structures in C#, and all this is due to the fact that the constructors now are taking the names of the courses as a parameter. Here is the class that serves the purpose. So there is the very simple constructor and the equally simple auto-implemented property. So that's our current version of the program, and generally the default constructor is not very useful, so typically we write our own constructors. And now our UML class diagram changed too, because we have constructors, and that's also in UML indicated by gilmats, the arrowhead quotes. So here it is. Again, the class diagram has 3 compartments. The first is the name of the class. The property course name is a string, and the plus sign indicates that it's public. And we have a constructor, also public, of course, gradebook, that takes one parameter string and have one method left, still there, display message. So let me stop here, and in the next segment we look at one more example of a class, and in later segments we take more detailed looks at classes, objects, and methods.